So for the first set of problems, they're just asking us to practice writing the vector in the component form and then in that linear combination form, which is new from last night's video. So we just have to look at where the vector starts. And sorry, that one kind of looked like it started in between. And then we count how far left or right it goes to the arrow. So this one goes left. And then we count how far up or down it goes. So this one went left 2 and up 3. So the component form would be -2, 3. And the linear combination form would be -2i plus 3j. So the problems are not meant to be difficult, they're just practicing the two different forms. What about if we look at problem number 5? Does that one go left or right at all? No, so we're going to say 0. And then if we count, it goes down 9, so I'm going to say 0, -9. And for the linear combination form, you could technically say 0i minus 9j, but most people would not put the 0i. They would just put -9j as the linear combination form and leave it like that. So it's not wrong if you put the 0i in the front, just know that if you see a problem, it probably wouldn't have that. Okay, does that make sense for the first section? Yes? Okay. And then for the second section, you're going to draw the vector, and it gives it to you in that linear combination form. So if you would prefer to think of it as component form, you can convert it if you want, but they're about the same. Now, with vectors, it does not matter where you start them. So if you want to start at 0, 0 and draw it in standard position, that's fine. But if you want to start over here, that's also fine. Or if you want to start over here, that's also fine. You can draw this one starting wherever you want. The important part is what direction you go from there. So from wherever you start, what should you do? Not the left 3 up 2, yeah. So as long as you go left 3 up 2 and then put your arrow, you are right no matter where you drew it. All right? So I'm going to give you guys a few minutes to work on that front page. Okay, so for this page, we have to know what they mean when they say dot product. So let's go ahead and get that formula from our notes. So in your notes it says A1I plus B1J and A2I plus B2J, and then what's the actual dot product? Yeah, A1 times A2 plus B1 times B2. So that means you're going to take the number of the horizontal component and you're going to multiply them together. And you're going to take the numbers of the vertical components, you're going to multiply them together, then you're going to add those two numbers. So when you find the dot product, you don't get a vector as the answer, you get a single number as the answer. Okay? So let's go ahead and do a few of those. For this one, we're going to say V dot W is the horizontal component for each of these is a 1. So 1 times 1 plus the vertical components would be -1 times +1. So what would that give us as a dot product? 0, yeah. So it'd be +1 plus -1 equals 0. All right, what if we try this one? So V dot W is going to be yeah, 2 times 1 plus 1 times 2, and so the dot product is 4. So when we work with vectors, we don't ever talk about multiplying vectors. We find the dot product of vectors. And the result is not a vector, it's a single number. Okay? One vector times another vector well, dotted, I guess, with another vector as a number. All right, let's try this one because it has that square root. So v dot w would be root 3 times 1 plus negative 1 times 1. And so what would the dot product be? It's going to have two parts to it. Root 3 minus 1. Yep, can't simplify it any more than that. Okay, so dot product, pretty easy to work with. You just have to kind of remember that little formula for it. And then next, we want to look at the angle between V and W. And there's a formula in your notes that says cos theta equals, and it's a fraction, and what goes on top? Anyone have it? And I think your notes say U and V, but we're going to do V and W. So usually it would be U dot V, right? But we're going to do V dot W. So the dot product goes on top, which is nice. We already found that. And then what goes on the bottom? Magnitude. Yeah, you see those two double lines? So the length of V multiplied by the length of W, or we call that the magnitude. So we're going to have magnitude of V times the magnitude of W, and then that's it. So then if we want to solve for theta, we're going to do the cos inverse of that fraction, and that's where the calculator comes in. For this unit, we're going to work in degrees. So right up here, I'm going to write a note to myself. This is in degrees. Okay. So before we're able to find this fraction right here, we have to find the magnitude for each of our vectors. So let's go ahead and do this for number 13. We're going to have the magnitude of V is, what should I put underneath that square root sign? So 1 squared plus negative 1 squared. And what does that give you? Yeah, square root 2. And then the magnitude of W is what? 1 squared plus 1 squared, which is also square root 2. And so at this point, we have all the different pieces that we need to find the angle between the two vectors. Now we just have to actually do it. So I'm going to say cos theta equals the dot product divided by the length of V times the length of W. And then in my calculator, I'm going to go ahead and cos inverse this so that I can solve for that theta. And don't forget to make sure that your mode is in degrees. So then I can do cos inverse of 0 divided by root 2 times root 2. Oops. And so I get that the angle is 90 degrees. Anyone remember from the video what it's called when two vectors come together to form a 90-degree angle? It starts with an O. Orthogonal. These are orthogonal vectors. Or orthogonal, if you want to pronounce it differently, I guess. No? Orthogonal? You don't think that sounds better? Oh, man. Crack myself up, you guys. Oh, that was a good one. That was a good one. All right, let's go down to number 17. So let's go ahead and find the magnitude of V. So what do we have to do? root 3 squared plus negative 1 squared. What does that give us? Yep, square root 4, which is 2, all right? And then the magnitude of W, just like the other one, we got 1 squared plus 1 squared. So now we just use our formula. So we're going to say cos theta equals dot product divided by the length of V times the length of W. And then I'm going to do cos inverse on each side. See, it's good because I got the answer already, but you guys can't see it. So you still have to type it yourselves. Ha! No? Tough crowd today. All right, what'd you guys get? 75. Me too. Look at that. Look at that. So our two answers, we had our dot product up here, and then we have our angle down there. And a 75-degree angle does not have a special name, so we have nothing else to write. All right, go ahead and work on that page. Have fun. Okay, so for this it says we're going to find the unit vector. And if you look at your notes, the formula for unit vector is you take the vector and you divide it by its length. So what a unit vector means is you have a vector that's a length of 1. That's what it means to be a unit. So if your vector originally is a length of 27, and you take the vector and you divide it by 27, then you're forcing it to be a length of 1. So that's basically what we're doing. So here, if we were to picture this vector right here, you can put plus 0j. This vector, if you were to graph it, it has its starting point, and then it just goes right 5, and that's all it does. It doesn't go up or down at all, it just goes right 5. Okay? So if we were to go and find the magnitude of this, you can already tell based on the drawing that the magnitude should be 5, because that's the length, and it just goes right 5. But if we go ahead and use the formula, then we would say the magnitude is 5 squared plus 0 squared, which gives you the square root of 25, right? 25 plus 0? Square root of 25? And the square root of 25 is just 5. And so now we go back and we say, okay, I'm going to take the vector itself and I'm going to divide it by its magnitude. So I'll say the unit vector is 5i divided by 5 plus 0j divided by 5. And if I simplify that, I get I plus 0j. And if I were to go and graph this, then it's a unit vector that's in the same direction as v. So you can see the angle is the same. It's still going towards 0 degrees, but now it's a length of 1 instead of a length of 5. That's what they mean by unit vector. You just made it short. Now, the part of the instructions that say your final answer should match the notation of the original problem, that just means that the original problem was written as i's and j's, and so your answer should be written as i's and j's. So it means don't switch it to component form. Leave it in the form that it's in. All right, let's try number 26. So first we're going to find the magnitude. So what am I going to do for this one? So we have 25 plus 121. 25 plus 121 is 146. Okay. 146, perfect. And so now we're going to keep the notation the same. So we're still going to do i's and j's. So I'm going to say the unit vector is negative 5i over the square root of 146 plus 11j over the square root of 146. And if you were doing a free response problem, that is a perfect answer. You can leave it like that. I'm fine with that. All right. And the higher up in math you go, the less likely it will be that they want you to fix that. However, we have a multiple choice exam, like your final exam for this class is multiple choice, and I do a lot of multiple choice questions. So we need to make sure that if they did fix this, because you're technically not supposed to have a radical on the bottom, that if we fix this, we need to know how to do that so that we can match it with a multiple choice problem, all right? So if we wanted to do that, we would multiply the top by square root of 146 and multiply the bottom by the square root of 146. And so that would give us negative 5 square root 146i over 146 plus 11 square root 146j over 146. And so both of these answers are good. This one is just the one that might show up on a multiple choice problem. So we want to make sure we can work with that. And again, the problem started in i's and j's, and so I left my answer in terms of i's and j's. Okay, I want to do one more. We're going to do either 29 or 30 because they're in the other form. 30. All right. So if we do 30, we're going to start off the same way. We're still going to find the magnitude. So we have negative 2 squared plus 4 squared, square root of 20. Now 20 can be simplified, which again, if we do a multiple choice problem, might be the form that the answer's in. So if we were to think about 20 being simplified, that's 2 times 10, right? And then 10 is, 2 times 5. So we have a pair of 2's and a leftover 5. And so how do we write this? 2 outside, 5 inside. So 2 square roots of 5. Okay. So if they were to do this without simplifying at all, then you could say that your answer is negative 2 over the square root of 20, comma, 4 over the square root of 20. And that is the correct answer. It's just not simplified. So this would probably not be the multiple choice answer. So if we want to fix this and make it so it's probably looking like the multiple choice answer, then I would say this is negative 2 over 2 square root 5, 4 over 2 square root 5, and then I'm going to have to fix it. So I'm going to multiply by square root 5 on the top and square root 5 on the bottom. So on the top, we have negative 2 square root 5. On the bottom, we have that 2. And then root 5 times root 5 is... What's root 5 times root 5? 5. So we have 2 times 5 makes 10. And then here we have 4 root 5. And then we have the 2 on the bottom. And again, root 5 times root 5 makes 5. So we have 2 times 5 again is 10. And then can you simplify those fractions at all? Mm-hmm. You got a 2 over a 10 and a 4 over 10. Mm-hmm. So what do we do? Divide by 2. So we're going to have negative root 5 over 5, and then 2 root 5 over 5. And this is more likely to be what would show up as a multiple choice answer. So if you had a calculator, you could compare the decimals. The decimals would be the same. But do you see how different the answers look? Mm-hmm. So So we want to make sure that that's a skill that we have just in case we do need to do it that way. But the one I wrote up here in pencil, if you're just writing the answer out yourself, that one's totally fine. Okay? All right. So that is the last page. When you guys choose to take the optional quiz, if you choose to, the stuff that we learned on Friday and the stuff that we learned today is the stuff that will be on the optional quiz, and the optional quiz will be ready to take starting tomorrow. So the types of things you want to be comfortable with would be like, if I gave you 2 points, could you write a vector from the 2 points? If I gave you a picture of a vector, could you write it in the component form? Could you write it in the form with the i's and the j's? If I gave you a vector, could you find the magnitude of the vector? If I gave you 2 vectors, could you add them? Could you subtract them? Could you find the dot product between them? Could you find the angle between them? Could you find the unit vector? So really, you just want to make sure if you take that optional quiz that you have like a little bit of a cheat sheet that just has all those formulas on it. But really, the quiz should not be very difficult. All right? And as we've seen before, it's beneficial, right? The optional quiz is beneficial for your grade. All right?